Hi everyone, my name is Vishnupriya. I'm presently pursuing my bachelor's in computer science and engineering from Bangalore Institute of Technology. Today I'll be explaining one of the application of IoT, which is Internet of Things. This will be done by using a software online simulation tool. The application I've taken up is traffic light system. We'll be doing this by using the online tool which is available, which is called as Autodesk TinkerCAD. So we all know about traffic lights. We know that it has three colors, red, yellow, and green, where red means stop, yellow is to get ready, and green is to go. So by using this online tool, we will be making up the application of traffic lights. So the various materials which are used, the first one we make use is Arduino Uno. Arduino Uno is one of the variant of Arduino. Arduino is an advanced prototyping platform which is built by using simple equipments as well as programming language. The other materials which are used is breadboard. Then we make use of LEDs, one for red, one for yellow, and one for green. Then to show the timer, we make use of 7 segment display. And for the three lights as well as for the timer, we make use of 4 resistors, each of 220 ohms. Now, this is the basic circuit diagram that we'll be making use to build the traffic lights application. So it's not just traffic lights, but along with that, we'll also have a timer, which will show the amount of time for each light. So this is the basic circuit diagram that we will be making use of. So firstly, we have to go to the web browser. So now here we have to search for AutoCAD, Autodesk TinkerCAD. So when we search for it, the first link that appears, we have to click onto that. So if you are a new user, you will have to register yourself. Since I've already registered myself, I will just log in. So I'll be logging up with my Google account. So once we log into this platform, this platform is used to make 3D designs. It's used to make circuits. So since we are interested to make a circuit, so we will click on the create button and we'll select circuits. So before we start making up the circuit, let's just go back and see how the circuit diagram actually looks like. So here we have the Arduino board, and along with the Arduino board, we have the three traffic lights for three different lights, that is red, yellow, and green. And along with that, we also have three resistors, each of 220 ohms. And then for the timer, we also have this 7 segment display. So we'll start up with the Arduino board. So let's take the Arduino Uno board, which is over here. So it's very simple. You just have to click on the board, drag it, then keep it over here. So we can rotate this as well so that we can make space for the other components that we will be adding. So I'll make it a little smaller so that it'll be visible. So this is the Arduino board. So now apart from this, we will need three LEDs. So let's add the LEDs as well. So the first LED will be the red light. So the red LED, and then we will have the yellow LED. So we can change the color, and then we'll have the green LED over here. So we can change the color to green. So now we've added the Arduino board and the three LEDs. So we need to connect each of these three lights to the respective pins. So here we have the Arduino board ready, and we've also set up the three LEDs. The three LEDs that we've used is red, yellow, and green. Now we have to connect the three LEDs to the Arduino board. So this is the cathode and this is the anode. Same way, this is cathode, anode, cathode, anode. So we need to connect the cathode of all the three lights to the ground. So to make the connections a lot more easier, let's make use of a breadboard. So the breadboard is used to make the connections easier. So let's take a small breadboard and let's take the ground from the Arduino board and connect it to the cathode. So here, each and every cathode of every single LED will be connected to it. So we can change the color. We can make it black so that it represents ground. So we can make it black so that it will represent ground. So similarly, the cathode of the yellow LED will be connected to the ground. So we have done the first cathode connection. Now the anode connection. So to connect the anode of the LEDs, we make use of pin number 13, 12, and 11. So 13 is used to connect the red light. 12 will be used for the green light, and 11 will be used. 12 is used for the yellow light, and 11 is used for green light. So 13, we will be connecting it to one of the boards, to one of the pins. So 13 is for red light. So we will be using this and connecting it to the anode. The next is yellow. So for yellow, we'll be connecting it to pin number 12. So pin number 12. And then for the green light, we'll be making use of pin number 11. Okay, we wanted this to be yellow, right? So once this basic connection is done, we have connected all the anode to the ground, and all the cathode to the ground, and all the anode is connected to pin number 13, 12, and 11. So now there's another catch over here. We need to attach a resistor because the amount of current that passes will exceed the limit. So to each of the anode, we have to also connect a resistor. So let's take up a resistor and place it over here. So we have to set this to 220 ohms. Initially, by default, it is set as 1 kilo ohm. So we should set it to 220 ohms. Similarly, another resistor for the yellow light, we have to set it to 220 ohms. And the third resistor for the green light. So we need to connect the connection to this resistor. So it has to pass through the resistor and then over here. Similarly over here, um, so we have to first so this is how the basic connection is. So first we'll have all the cathodes of the LEDs which are connected to the ground, and the pin number 13, 12, and 11 of the Arduino board is connected to red, yellow, and green light respectively. But in between you have to attach a 220 ohm resistor. So after this connection is done, this is the basic LED light working. So apart from this, we also have a timer which has to be attached. The timer is going to basically show us the time, right? Like the number of seconds for which each of the lights will be on. So for using a timer, we will have to make use of seven segment display. So let's search for it. So we get something like this. So we can attach it over here. So here we need to change it to cathode. The common has to be cathode. So here to make it visible. So this is the seven segment display. So when we talk about it, first let's learn about how it works and then come back to how we are going to connect it to the Arduino board. So the seven segment display, it's going to look something like this. So over here we can see that there are several pin numbers, like we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and there's something called as ABCD. So each of these ABCD, which represents the pin. For here, A represents pin number 7, B 6, so on. So A is basically this horizontal line on top, B is this vertical line, C, D, E, F, G. Okay, and this is a dot, which is DP. So since there is 1, 2, 3, 4, 5, 6, 7, so there are basically 7 lines which make up a single digit. So if it is 1, then it is only B and C which will be on. The remaining A, G, D, E, F will be off. If it is number 2, then it is just A, B, G, E, D which will be on, which means that we have to connect only the pins A, B, G, E, D, and the rest of them will have to be off. Right, so that is how it is. If it is 3, then it is A, B, G, C, D which will be on. So this is how basically it works. So let's just go to the next slide where we can see that if it is decimal digit 0, right, so it's only the outer part which has to be on. So the outer part in sense it's only A, B, C, D, E, F. So G has to be off or 0. So except G, everything is set to 1 and G is 0. So this is the basic working principle of how the 7 segment works. So after understanding this basic thing, let's go back to make our circuit. So in the circuit as well, if we can see, this is common. The common has to be connected to the ground. So let's first do this common connection. It has to be connected to the ground, right? So it has to be connected to the ground. I'll just make it a bit larger so that it's visible. So we'll first concentrate only on the connections to the seven segment display, and then we'll see the entire circuit as whole. So this is common. This is your A, B. This is your DP, which is a dot, and this is C, D, E, F, and G. So we have to connect all of this to the board. So to connect it, we make use of pin number 2, 3, 4, 5, 6, 7, and 8. Right. So the A is connected to pin number 2. Okay, so we will make use of different colors to represent it. Now B is connected to pin number 3. So we can make use of different colors to represent it. So AB. So next we have C. C is connected to pin number 4. And then you have D is connected to pin number 5. So pin number 5 is connected to D. E is connected to pin number 6. And you have E, F. F is connected to pin number 7. And the last pin, which is G, is connected to pin number 8. Fine. So now you have the common. So the common has to be connected to the ground. So before you connect the common to the ground, you have to insert a resistor of 220 ohms. So first you have to insert a resistor of 220 ohms, just like how we did it for the 3 LEDs. So you have to connect the common to this resistor first, and then it has to be connected to the ground. So this is exactly how the connection works. This is the entire circuit diagram of what we have connected. So just to summarize fast, we'll have an Arduino board which is connected to a breadboard, and through the breadboard we are connecting to the three LEDs. So we have connected the three LEDs as well as to display the timer. We've also connected the 7 segment to the Arduino board. So this, the cathode, the common cathode that we have is connected to the Arduino board through a resistor of 220 ohms. So this is not it is, so we still have to code. So for the code, we have to go to this option, select for text, and then just remove whatever is the code that we have. So before we go on, so basically there are two basic functions which are used in Arduino, that is loop as well as setup. Setup basically tells all the pin modes, all the pins which are active, and loop is the basic logic that we use. So I will remove this code. We're writing the code in C++, which is a basic programming language which most of them would know. So let me just explain the code separately and then use that code. So this is the code that we'll be making use of for this LED, for the traffic lights. So here, what have we done is we have LED 1, 2, 3. This is the basic initialization that we're doing. So we are telling that LED 1 is pin number 2. We've already, so I'll show it along with the code. I'll explain it along with the circuit diagram. So over here, pin number 2, 3, 4, 5, 6, so on till 8 is connected to the 7 segment display. So that is what we have over here. That is your pin number 2, 3, 4, 5, 6, 7, 8 is connected to the 8 is connected to the 7 segment display, and pin number 11, 12, and 13 is connected to green, yellow, and red light. So that is what we're going to initialize. So whatever we have done in the board, so 11 is connected to green, 12 is to yellow, and 13 is to red. This is the basic initialization that we're doing. Now inside the first function setup, we're going to set up each of them as an output. So LED 1 as output, LED 2 as output, 3 as output, 4 as output, and so on. Right. So apart from that, in loop, so in loop we'll have the basic logic. So in loop, we're writing the logic for when the red light is on, when the yellow light is on, and when the green light should be on. So in this program, we are going to set the red light first to be on for 10 seconds from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then after that, the red light goes off and the yellow light is on for 5 seconds, 0, 1, 2, 3, 4. And then the green light is on and all the remaining two lights will be off. The green light will be on for 10 seconds, that is from 0 to 9. So we usually, when we go to the traffic signal or road, we find that the red and green lights time duration will be longer as compared to the yellow light. So that's the reason why the yellow light duration is just 5 seconds and the remaining is for 10 seconds. The first code that we have is when the red light is on. So when the red light is on, the red has to be set to 1. The yellow and green is set to 0, which means the yellow and green light has to be off. This is initially when the red light is on. So when the red light is on, we have to count from 0 to 9. So we are doing it in the backward direction, like 9, 8, 7, 6, so on. So now this is when 9. So when 9 has to be displayed according to our logic of how the 7 segment thing works. So everything has to be on except your LED 5, except your LED 5. Right. So we have seen the logic of how the 9 works. So except LED 5, everything has to be on. Only then 9 will be shown. Okay, so after 1 second of delay, then we have to change the number to 8. So for 8, every single LED has to be on, right? That is your A, B, C, D, E, F. Everything has to be on. Similarly, for 7, all your LEDs will be on, except your LED 4, 5, 6, and 6, 7. So this is the logic. So this is when the red light is on, right? So in all of these cases, red is set to 1 and the remaining two lights is 0. So this is 6, 5, 4, 3, 2, and 1, and 0. So after 0, your red light goes off. Your red light goes off and yellow light is set to 1. And again, it counts from 4, 3, 2, 1, and 0. So after 0, your yellow light goes off and your green light is on. And it starts counting from 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. So this is the basic logic of how it works. So I'll be using the same code and I'll show you how the simulation works. So we need to go to code and then paste our code over here, and then we can start the simulation. So let's just see the entire circuit of how it works. Okay, so let's start the simulation. It will first initialize whatever code we've done, and it will start working. So we can see the red LED is on. It's counting from 9, 6, 5, 4, 3, 2, and 1. So after 10 seconds, that is after it goes to 0, the red LED is off and the yellow LED turns on. And this counts for 5 seconds. And the yellow LED goes off and the green LED is on for the next 10 seconds. It counts from 9 to 0. And again, the process again starts with the red LED on for 10 seconds. Then the red LED goes off after 10 seconds. And then we have the yellow LED that starts for 5 seconds. And then after 5 seconds, again, the yellow is off and the red LED turns on and runs for the next 10 seconds. So this is the basic working of how the traffic light system works by making use of Arduino board and by making use of the online simulation tool. Thank you so much.